So the purpose of this lab is to find what kind of fabrics henna dyes best. The independent variable are the different kinds of fabrics, and the dependent variable is how well the henna is stuck to each kind of fabric. The controls are how long the henna stayed on the fabric, the henna formula, the washing method, and the color of the fabric. Okay, so our hypothesis is that henna would stick best to cotton because of the high cellulose level of cotton. The high cellulose level will make the henna latch onto the cotton easier. The next darkest stain will be on the wool because the wool is slightly basic and will attract the acidic henna. This attraction will not be as strong as the cellulose attraction. The henna won't stain the satin or polyester very well because they're both made with a coating made of synthetic materials. Synthetic materials do not get stained by natural dyes easily because natural dyes are often not strong enough to get inside the synthetic materials and the threads. The felt will have the lightest stain because the material felt is made of is hydrophobic, meaning it repels water. And because there's a lot of water in henna, this will prevent the henna from dyeing the felt.
The materials needed for this lab were wool, cotton, satin, polyester, felt, henna powder, and lemon juice. To measure the intensity of the henna stains on the different fabrics, we used Drunos. A Druno is a unit created specifically for this lab. It rates how dark the henna stain is on a scale of 0 to 15. For this lab, we mixed 4 grams of henna powder with 9.8 milliliters of lemon juice, then put the henna in small squares on each fabric for 20 minutes. Finally, we gently washed off the excess henna with distilled water.
So for our data collection, we decided to ask 5 different people to give their opinions on where each henna-dyed cloth fit into the Druno scale. For example, person number 2 rated polyester at 1, wool at 13, cotton at 10, the craft felt at 5, and the satin at 6. As for the qualitative observations, well, for example, wool we had at 5 minutes, the henna was pasty. At 10 minutes, the henna was drying fairly fast. At 15 minutes, a lot of the sediment on the top, it was visible, and there was a small ring of the liquid from the henna around it. And afterwards, after you wash it off, it was a very dark orangish brown.
Yeah. After collecting the data, we found that wool had been dyed the darkest, not cotton. Wool had an average of 14.4 Drunos, cotton with 11.2, satin had 7.3, polyester had 1.3, and felt with 6.
In our hypothesis, we said that the henna would dye the cotton the best because of the cotton's high cellulose level, but we turned out to be wrong. The henna bonded with the wool the best because the wool is slightly basic and because the henna mixture is acidic from the lemon juice. The wool attracted the henna and stained it the best. What we correctly predicted was that the satin, polyester, and felt not being stained very well by the henna. We could tell this was going to happen because synthetic materials are often made of plastic and repel dyes.
One systematic error that occurred in our lab was that the felt's matted material kept in the sediment from the henna. This skewed the amount of Drunos the felt should have received. What we learned is that henna dyes wool and cotton the best because cotton and wool are both natural materials, just like henna. This is important to know because if someone was trying to dye cloth with henna, they would know that they should use natural fabrics like cotton or wool and not synthetic ones like polyester, satin, or felt because those fabrics repel natural dyes.